Hello, calculus fans! Well, we're going to finish up our discussion of vector calculus by just summarizing all of the different key theorems that we've talked about in this section. Now, the fundamental theorem of calculus comes from first semester calculus, but in this section we've talked about the fundamental theorem for line integrals, Green's theorem, Stokes' theorem, and the divergence theorem. And I think the thing to take away from all of this is that these four integral formulas from this chapter, the FTC for line integrals, Green's theorem, Stokes' theorem, and the divergence theorem, they are, in a way, just a variation of the fundamental theorem of calculus. They all involve a derivative. So for the FTC for line integrals, it's the gradient. For Green's theorem, it's dq by dx minus dp by dy. For Stokes' theorem, it's the curl of a vector field, and for the divergence theorem, it's the divergence of a vector field. And then we compute that integral by just seeing what happens at the boundary. In the case of the FTC for line integrals, it's just like the regular FTC. You subtract the values of the potential function at the endpoints. For Green's theorem, Stokes' theorem, and the divergence theorem, you have to compute an integral, but that integral just goes along the boundary. For Green's theorem and Stokes' theorem, you're computing a line integral along a boundary. For the divergence theorem, you're computing a surface integral. So really, all of these, they're not the same theorem, but they're all variations of the fundamental theorem of calculus. That's it. Nothing else that we're going to talk about in this chapter, and we've ended our study of multivariable calculus. So, for the last time, that's all for now.